Okay. Google Classroom. Okay. Sorry, bear with me for one more second. I just want to make, this is important enough to be, oh, and someone's here. Bear with me twice. I mean, someone's in the waiting room. Okay. Oh. Okay.
I have a question about the turns. Can we do the majority of them towards the beginning of the semester, just so that when finals time comes around, we're not rushing to get things done?
Oh, wait. Oh, yeah. Oh, absolutely. Wait, there might be confusion about that. Hold on. Great question. If I understand your question correctly, the answer is not only yes, but that is supposed to be the idea. Yes. Let me be. So give me a second, but yes, absolutely. Hold on. Hold on. Let me just get this. Okay. Okay. Well, why is this not? Okay. Okay. Let me address that question. Then I want to address this grading rubric, and then hopefully we have time to. And I'm sorry, who just asked that actually? Not that it matters really, but who just asked? Was that
Marina?
Oh, Marina. Okay, thank you, Marina. Okay, so yeah, if you're talking about anything that's any of those game participation portals that don't say turn on them, all of those things like show video or show avatar or multiplayer co-op, all of those things, right? I don't expect you to wait to the end. I'm just saying you have all the way to the end of the semester to do them at any time. The whole idea of those is at any time, including right now, any time, like any day that you show video, like, or you, for example, Marina, like you're using your voice, you're talking with your voice. So that portal that says speak now or forever hold it, like you could fill that out right now or tonight and submit it for points, and you get the points right now. And then if you use your voice again next week, fill it out again next week. They're to be used.
Oh, wow. So it can be done more than once.
Yeah. Everybody.
Oh, that's awesome.
Oh, good. Okay. I'm glad you're asking. Yeah, to all of you, that's the whole point of those portals is anytime you participate in any way, or I should say any week that you participate in any way that any of those portals applies to, just fill it in and submit it, and you get the points for that week. And yes, you could do them more than once, absolutely, and get
So
more than
there's, sorry. So there's tongue-tied. So there's an unlimited amount of points we can get, basically, like if we keep doing them.
Right.
Oh, that's amazing. That's great.
And that's why I say, no, that's good. Okay, no, I'm glad you're clarifying this. And I know it's an unusual system. I mean, it does take, I mean, it is an unusual system, but, and yes, it's unlimited, but this is also why I say to everybody. So yeah, hopefully we're understanding. And if you want to take a moment, all of you, if you want to make sure you understand, you could right now look at those portals and see anything that applies to you right now. Fill one out right now if you want. You can do it every week. And you get the points for them. I mean, of course, I have to turn it back to you to get the points, but I will. Yes, the pile of points could potentially be unlimited. And what happens at the end, of course, I scale it down. Like at the end, I will take their total number of points and divide it by one certain scaling factor that will apply to everybody. So, and then that, when I divide it by the scale, like, so if you got 200 points by the end of the semester, and at the end of the semester, the scaling factor is 20, then I divide your 200 by 20. That means 10 points are added to your exam grade or whatever. But right, if you do them all the time, then 20 points could be added to your exam grade, or 30, which is another reason that the more you all do this and the more we keep having all these discussions and the more you all stay with me in discussion and participate, the less of an emphasis has to be made by exam scores or other things. Like yes, that's the whole point. And I don't expect you to wait till the whole end. Do them whenever, wherever, for sure. And I think it's especially important in a Zoom class like this, where there needs, where it's like hard to participate in stuff. So yes, I'm glad that Marina just clarified that. Does it make sense to people what I'm saying? Like, or did it make?
And thank you for clarifying that, because I was just assuming, okay, you do it once and that's it, you get your points, and
No, you could do it as many times as it applies. It's to encourage you guys to keep staying with me like this, really. And you're going to see this, right? No, really. And again, well, anyway, yeah. Wait, raise your electronic hand, all of you, if you understand what just got clarified. Okay, awesome. And thank you, Sylvie, and thank you, Catherine, and thank you, Kayla. And even that, I should open a portal for that. Like literally, like just raise your hand like that. That's participation. That helps. I'll open a portal for that if I think of it, or when I think of it, or you can remind me. Okay. I mean, the more points you can all get, there are people in my other physics classes who do very badly on exams and still get an A because they've submitted so many of these things. That is the point. And it's not a gift. And it's not a joke. I mean, it's not, in the sense that the reason it works and the reason I keep doing the system is there's always enough people that don't do it. I mean, it still requires that you have to participate, and it requires you have to remember that you participated and take a moment to reflect on that and write in. But it sure beats taking an exam. I mean, so anyway, you get the point. Okay, good. Okay, so speaking of grading, back. And I know I do have to set you up for the next lab, though. It's going to be a little. Let me quickly say about the grade. Good question in the direct chat. Oh, wait. Okay. Wait a sec. All right, in direct chat, if we keep going like this, and don't get me wrong, there will be a midterm exam in this class. Like, we do have to have some exams, and there will be a final exam in this class. But we're trying to keep the workload as streamlined as possible. We're trying to have as few big lab reports and things as possible. So probably if things keep going like this and you keep participating like this and we keep hanging together to answer a question that's in the direct chat, probably your final exam in the whole class will cover lecture and lab, and you probably won't have to have a separate lab exam. Someone just asked that in direct chat. Okay, that's probably the answer to that. Okay, cool. And then I'm getting a little concerned because I do want to make sure you're set up for the next lab. So I am watching the clock. So I'm a little concerned about that, just to be clear. So please know that. But Fatima is asking, you have a question about exams. So yeah.
Yeah, so I wanted to know, like, how are you going to structure them? Like, because I know, like, we're on Zoom and stuff. I figure we're taking them online, but how long are they going to be, like, questions and stuff like that?
Okay, fair question. I'm going to give you the overall answer right now, so we'll get to much more details as we get closer. But here's the overall answer is, yeah, we have a midterm exam and we have a final exam. But I'm going to tell you right now, people, they're both take home. and they're both untimed. And you both of them you submit on Google Classroom. And usually I give you a practice document before the exam that even shows you what's on the exam, so it's not even a surprise when you get it. Okay. We'll talk in more detail, and it's usually like 3 long problems. We'll talk, or it's like 3 big homework assignments, like put together in terms of length. Usually they would take, if you just sat down and did it straight up, like if you did it straight from beginning to end, they usually would take like 2.5 hours to 3 hours, like in other words, a full period, but they're not timed. You take them home, they're more like a project or like that, or like consider it like a research paper or whatever. They're
So we have
untimed.
a few days to get it done.
That's correct. And we will talk about it. Okay, fine. So we'll talk about it more when we get closer, but that's correct. I'm telling you again, all of you, and I'm not saying all this, let me tell you again, I've been doing this for 30 years, okay? I don't mean that to brag, but I mean, I've seen things come and go. I've seen things change. I've tried different things. I'm not saying all this to prove to you that I'm a nice guy, and I'm not saying all this to make it a joke so that I'm not saying you could just end the class, you could walk away from the class right now and you're all guaranteed an A. Not at all. There are people that won't get an A. There are people every semester that get an F or a D in the class. Just to be clear, it is possible to get an F or a D in this class. But the way to get an F or a D in this class is to not stay with the class. The class is designed so that if you guys stay with me and you hang with me and you listen and you relax and you actually try to learn, there's a million systems set up so that if you try to learn and you relax into the material and you try to enjoy the material, then you stay with it, you will be fine. And the take-home exams are an example of that. I will tell you right now, there are people that fail those exams. It's not a joke. You still have to do it. But we'll talk about it when we get there. It's I don't want to like set up false expectations. The reason I can get away with all these crazy systems is that every semester, enough people do mess them up that it saves the curve that no one can look at all the grades and say, wait, Yavrabam is just gifting everybody an A. I'm not. Some people will not get an A and some people will not even get a C. But most of you, especially if you're hearing my voice right now, if you're still with me at 6:30 in the middle of this, most of you will get a really good grade. And part of it will be because, yes, you'll have like 3 days to take this exam. Yes. So, okay. So don't stress it. So I'm going to does that make sense? Are we good?
Yeah,
okay.
That makes sense. So to confirm though, we only have 2 exams?
Correct. Well, correct.
The final.
Correct.
Okay. Okay.
All right. Cool. Okay.
And no lab exam, right?
Almost. I mean, I reserve the right. We reserve the right to have a lab exam if we think like lab really starts falling apart, if people are cutting in and stuff. Like if we're allowed to give a lab exam, and we reserve the right. But I will again tell you right now, if things keep going like this and everybody stays with it and keeps doing the labs, we don't want to give you a lab exam. We don't need to give you a lab exam as long as
that would be great.
Okay. All right. So we're fine. Okay. Let's all get an A. Good plan. Good plan. Okay. Okay. So that said, let me say one more thing about grade. And again, I feel like when we get in these conversations, sometimes I feel like some people might think I'm just, I'm saying all this because I'm not trying to get you out of learning or me out of teaching. I want you to learn a lot of physics and I want you to love physics. But yeah, I want to do it with the stress of the grades to the side so we can just relax into the physics. That is the point. I know somebody already acknowledged, but just to be, and again, it works as long as you stay with me. And it works because for some people it doesn't. I can continue doing this system because there's always just enough bad grades that that it all looks good on paper for everybody else, honestly. So just know that. Just don't be one of those people. Just don't be one of the people that saves this system for everybody else. Be one of the people that benefits from the system. Okay. Now, on that note, as far as what we're playing, maybe the way we plan on grading you in the lab is this. It's what's in the chat. And could someone check, by the way, I feel like I just posted it in Google Classroom, but I don't know if the document went through. If someone could check whether
You did, I saw it. You're
And it's
good.
there, okay, and it's
Yeah.
actually a document that you could open, like it said, okay.
Yeah.
All right, cool. So very quickly, this is how it's meant to work. You'll come into lab every week. And so that you can get a grade, a proper grade, and be graded, and so that you can all focus, but so that we don't have to stress about a lot of formal report. You will have some formal report, don't get me wrong. You will have some reports, but so that we don't have to do it every week or have lab quizzes or anything like that. What we're going to say is this: each week you're going to get 20 points, up to 20 points for your work in the lab. And they're all the points are going to, and then we'll, and then they'll all be averaged at the end to get you a lab grade, but you'll get 20 points for each lab. You get 5 points for showing up and staying in a respectful, engaged way throughout the lab. As long as you come and you stay and you don't like have like a 45-minute cigarette break, whatever, that's 5 points out of the 20 right there. That Professor will tally, will give you like on the spot, in effect. You get 5 out of the 20 points for being there, which conversely, by the way, does mean if you don't show up to a lab, you don't get those points. And we do have to be clear about that. Like, you got to do the labs, otherwise this doesn't work, right? Okay, whatever. So you get 5 points for showing on time and working attentively for the full period. Then after that, there's 5 other groups of 1 to 3. You're going to be graded right there in real time by Professor Tally, like in real time. She's going to give you from 1 to 3 on each one of these metrics. Okay. And you notice there's not one metric for accuracy of results. That is not a metric, but like on a scale from 1 to, so she's just going to walk around from here, and part of her job is just to monitor this and to make sure we're all good. And part of her job will be to let you know if she thinks any of you is slipping in any one of these metrics during the day. She'll be able to say, by the way, if you want to raise this up, like I suggest. So you get 1 to 3, anywhere from 1 to 3 points for data collection. 1 is the worst, 3 is the best, 2 is the middle. And she and I have already talked about this. I'm going to make it clear to you right now. The default, there's a reason there's an odd number. There's a reason there's a middle, because that's the default. Like, you, to get a 1 in any one of these metrics, you'd actually have to be noticeably doing something noticeably like counterproductive or destructive or bad attitude, or like noticeably irresponsible to get a 1. The basic assumption is if she doesn't like notice you at all and you're just like there, and she doesn't like have a clear sense of anything, then already the assumption would be you're at least getting a 2, if not a 3. To get a 1, you'd have to be, so data collection means just that. Like, are you making measurements? Have you set up some well, you get data collection. This is making measurements, taking down numbers. So you're automatically getting a 2 if you're doing it at all. And if you're doing it with any noticeable cleverness or noticeable thoroughness or noticeable care, then you'll get a 3. And I'm telling you right now that she and I have talked about this, and her attitude will be just like mine, which is, when in doubt, the tie goes to the runner. If she can find it in her heart anyway, if there's any slight evidence at all for you to be deserving of 3, she'll err on the side of 3. But, but the default is 2. So there's data collection. Then analysis means anything and everything. Analysis means, like trying to put your data into a graph, trying to read the graph, trying to make a line, or try to put your data into a scatter plot, setting up your axes, trying to do a best fit line for the scatter plot, choosing your software, whether it's Desmos, whatever. Everything that you do with data is called analysis. Oh, and I should back up. I'm sorry. Part of data collection, we should have a separate category for this, but we don't. When I say data collection, yes, that means measurement, numbers, but it also means the design of the data collection. Because as you see, as Remy has pointed out, we leave it up to you to figure out in large part how to collect data. So the whole process of figuring out how you're going to collect the data, setting up the measurements, that's all scale 1 to 3. Analysis, so that's like the beginning stages. Then you have your data, then you're analyzing it, you're setting up graphs, scale of 1 to 3. Contribution to group, pretty important, right? Like, it doesn't mean you have to talk all the time, but here's where you know it and I know it. If we're not careful and we're not being watched, or we're not on our game, here's where on an off day, a lot of people could get a 1, right? I mean, if you're just fading, if you're just like if you're piggyback, or what do you call it? Coattailing off someone else, if you're being dead weight, if whatever, this is what we're trying to avoid. This is where you really want to try to get a 2 or 3 is actually be a group member and have a good spirit and encourage anybody who wants to stay and ask questions and not get at it, blah, 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 blah. You get it. Then the next 2 categories, they sound more philosophical and abstract, but they're also pretty, as we progress more and more in the labs will get harder, of course. They will get harder, as Jake was implying, and they will get into territory you have not seen before, as Jake was implying. So it's going to be increasingly important as you're doing labs, both to make a noticeable, to noticeably be trying to use whatever material we've learned in the prior labs and in lecture. More and more, it's going to be hard to do a lab without trying to tie together the material. And we told you, or once I mentioned, this whole curriculum does build absolutely step by step toward a goal. So keeping track of how these labs are connected and how they're connected to the lecture is absolutely important. So you're scaled on that. But then conversely, an experiment is not an experiment if you're rigidly tied to your prior expectations or to anything that you think you learned last week. Like, to do an experiment properly, you have to be open to new ideas. And what that really means to a lot of us, and this is a really tricky part, it means you really have to be willing to change your mind. Like, you really have to be willing to change your mind. You have to be willing to admit you're wrong, or just that. You have to be willing to admit you're wrong to do an experiment well. So, bottom line, the way I want these labs to work is that most of that I'm going to tell you usually in advance, and I don't have that much time now to do it, but I'm going to tell you in advance basically what you're trying to do when you get to the lab. You're going to get to the lab and have a basic goal in mind. It's going to be up to you to design how you're going to get to that goal. Yes, Professor Talley is going to know the material and know what's right or wrong and be able to guide you, but mostly you're working on your own. And Professor Talley is going to be walking around to monitor these things in real time. And again, sure, give you feedback at any moment if she feels like you're slipping on any one of these metrics. Bottom line, again, if every one of you gets a 20 every time, great. It's not a problem. We're not looking for you not to get a 20, but this is the way to get a 20, is to get 3s out of those 5 metrics, and then the 5 for being there the whole time. And you shouldn't consider 2. This is also designed, if you look at it carefully, you'll notice if you got 2 on all of those metrics, but you also got the 5 for being there, you would get a 15 out of 20, which is 75%. So that means if you sit through the lab and you just vanilla the whole time, and you just don't do anything interesting at all, but you're just there, vanilla, you get a C, which is as it should be, right? It's not failing, but it's not anything extraordinary. And most of you will get somewhere between 2s and 3s on most of this stuff. But but none of it has to do with whether you get accurate results, and none of it has to do with formal reports. It's just how you're working in the lab. That's ideally, you'll have accumulated up to 20 points on each lab period. And ideally, you'll be able to know right then from Professor Talley how many points you got or not, starting next week. And that's it. Does that make sense?
Yes, but my question is, it's 1 to 3, right? So it's not possible for you to get 0 points in one of these different aspects.
That is a good observation. Correct. That's right. There's a reason. Yes, you're right. Good point. Yeah. Okay. So yeah, that's right. Now, if you did get 1s in all, just also note this though. If you got a 1 in all 5 of those categories, then you get 5. You get a 10 out of 20 for the day, which is 50%, which is an F. So you don't want to get 1s in all. But you're right. You won't get 0s. That's true. All right. So we're clear there. Now we don't have a ton of time. But now to set up for the next lab, okay, let me cut to the next lab. Very, very similar. Spray different. Well, I'll show you. I need my board now, and you're going to want to write this down. Please. I mean, obviously, Professor Talley will have it also, but here comes the board. Hold on 1 second. Sorry. So it's very similar to this last one. Same equipment, same. So it's about springs again. So it's not a major leap into the unknown. And it's the same kind of thing where Well, here we go. Okay. 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 You please write this down in case, especially if my board goes. For last week, you had one statement you had to verify whether it's true or false. As Jake and other people pointed out, like you pretty much, most of you already knew that statement, fine. This week, it's still springs, still same equipment, still same setup, but you got 4 statements. I got to explain 2 symbols here pretty quickly. You got 4 statements. Some of them are true, some of them are false. In fact, I'll even tell you right now, well, I think, should I just give this away? I think, well, I think one of them is true. At least one of them is true. At least one of them is true. Most of them, at least half of them are false. But you got to figure out which one is the true one, is really the goal of next lab. Now, again, same equipment, so I can save time on that. And same idea that you're going to figure out how to take data with that same equipment, and you're going to put together the data and make graphs and then see what the graphs look like. It's the same type of idea as last week, only it's a little bit harder now. There's 3 things I have to explain here. First of all, okay, M stands for mass, just like last week. M stands for mass. And I think it'll be assumed that M will be the independent variable that, well, usually that you'll try different masses on a spring, just like last week. X naught or Y naught, you could call it, would be initial stretch, initial displacement of mass on spring. I'll explain that more in a moment. But X naught means how far the spring is stretched initially when you start your data collection. Now, what does capital T stand for? Capital T stands for period. And please write this down because I'm going to lose my board. I'll try to in a moment, but please write this down. Capital T stands for period. It's measured in seconds. It means period for one full cycle or one full oscillation of a mass on a spring. Okay, so in this lab, you're going to be putting masses on springs and pulling them down a little bit and letting them go and letting them cycle back and forth. Like you have to be careful. You'll be a little bit more gentle here. And there may be even a little bit more error in this one. But, and I won't forget to, I will eventually get to uncertainty and all that. There's not time today. But here you're going to put a mass on a spring, pull it down a little bit, let it go, and it's going to bounce back and forth and bounce and forth, back and forth. Oh, one other piece of equipment you'll get this time as well is stopwatches. And if all the stopwatches are broken, you'll use iPhones, so to speak. But you're going to watch the mass go back and forth, cycling, oscillating on the spring. And you're going to measure how much time it takes for the mass to make a full cycle, like go up and then go down. The amount of time it takes to make one full cycle is what we refer to as the period, capital T, okay? I will tell you right now, as an experimental design technique or trick, just like I told you last week, it's better to use vertical springs than horizontal. First of all, again, this week, I would recommend using vertical springs again, just like the same setup as last week. But I'll also tell you now that if your goal is to measure how much time it takes a spring to make, or a mass to make one full cycle is going to be pretty quick. I mean, it's going to go like burp, burp. And that's pretty hard to measure accurately on a stopwatch. So you might already see where I'm going with this. The general technique that physicists do is what they do is they let a mass go, and they'll let it go like 20 times or something, some number like 20. And they start their stopwatch as soon as it's going, and they stop their stopwatch as soon as it's finished, like 20 cycles. And they write down that time and they divide it by 20, if you follow me. Like, you don't have to do that, but that's a strong suggestion. Or you could do anything else that you think makes sense. But what you're looking at here, you're going to be looking at the amount of time it takes for a mass to undergo a full cycle. Okay, that's number one. number two, what's that symbol that I've written between T and M? You may or may not know it. I mean, technically that symbol is a lowercase alpha, the Greek letter alpha, it's lowercase, but what it stands for, and please put this in your notes again, I'm sort of worried about my board right now, and I'm also worried about going into a rabbit hole. What that symbol means is directly proportional to, okay? So put in English or put in other mathematical terms, what that symbol really means is a linear function of, would produce a straight line graph, okay? Like, put one last final way, it doesn't mean equal. Directly proportional doesn't mean equal. But what it technically means, and maybe you should put this in your notes, if we say T is directly proportional to M, what we really mean is T is equal to some constant times M. That's what directly proportional means. Like, we might not know what that constant is, but we believe it's a constant, right? So just like with your last lab, like to say that this value is directly proportional to that value, to say that Y is directly proportional to X means that the graph of Y to X is a straight line graph, i.e. Y equals mx, like Y equals some slope times X. We might not know what the slope is, but as long as the slope is constant, then Y and X are in a straight line relationship or a directly proportional relationship. So this symbol means that if I say that T is directly proportional to M, it means I'm saying that T equals some constant times M, and I might not know or even yet care what that constant is, but I believe it's a constant that doesn't change, okay? So we're getting there here. I'm just changing the view of the screen. Sorry, 1 second. So what I'm saying is that for the most part, your data collection procedure next week, even if last week felt confusing or unstructured, you're pretty much going to do the same thing next week. What you're going to do, well, at least, for example, to test this first statement, you want to find out if period of oscillation for a spring is directly proportional to how much mass is on that spring. So you would put one mass on the spring, a mass of a known value, and you would set it in motion and let it oscillate like 20 times. Measure the amount of time for those 20, divide by 20. So now you have the mass, and that would be your independent value. And you have your period, that would be your dependent value. And then go to another mass, get another period, go to another mass, go to another period, and then you make a scatter plot of all your mass values and all your period values. And if it's a straight line, then that first statement is correct. Okay, in that sense, I hope this is what I'm saying is not going to be so bad compared, since really feels like you really did rock last week, and I'm not kidding. Like, it feels like you got yourself to the finish line of last week. Well, this is very similar. Now, the only issue here, the only differences are, one, we're now looking at period. What we're ultimately trying to figure out here, the ultimate thing is, what is it that determines or affects the period of oscillation for a mass on a spring? And in a way, what I'm giving is different choices, and I'm trying to figure out, like, one of them is true, okay? I mean, 3 of them are false, and one of them is true. And we're trying to figure out which one it is. We're trying to figure out what it is, what about the setup of a mass on a spring ultimately yields the period of oscillation for that spring. So the first choice, so I would test each one of these one by one. And whichever one gives you a straight line graph, then it's true. Okay. But now I'm assuming you're with me so far. Hold on. We have 20 minutes. Hold on. Let me just pause for a second. Are you with me so far? Does this make sense so far? Okay, cool. Thank you, Sylvia. I saw that. Thank you, Kate. Okay. Thank you. Okay. I would start with that top choice. I think it's the most straightforward. If I'm making sense so far, again, you would just measure a bunch of different masses and then measure a bunch of different periods. And if you get a straight line graph, then it's true. And then, to be honest, in a way, well, in a way, you'd be done in a way, because I'll tell you right now, if you're following the logic of this, if that first statement is true, then I don't think the second statement is true or the third statement is true. The fourth one still also could be. So I want to address that in a second. But like the first three statements are three different options. Only one of them could be true. What they're saying in English is the three different options are, does period depend directly on the mass? Or does period depend on the square root of the mass? Or does period depend on the square of the mass? And I will tell you right now, they're not arbitrary choices. Like really, one of them is true. And they can't, and two of them can't be true. Only one of them could be true, and one of them is true. So whenever you hit the one that's true, I guess in theory, you don't have to test the other ones in theory, but you might want to be careful. But one of them is true. I want to talk more about the middle one is sort of hard, and the third one is sort of hard to understand in a way. But before I even get into that, the very last option is a different idea. The very last option could be true or false, independent of the other three. Like you've got to test the last one, no matter what you find about the first three, because it doesn't contradict any of the first three. The last one is asking, does the period of oscillation, the last one is saying, forget about how much mass is on the spring. Like the mass may be having some effect on the period, but what about where we start the mass? Because remember, this mass is not going to oscillate at all. If you just place the mass there and if you just place it in equilibrium and walk away, well, it's at equilibrium, it's just going to sit there. The only way this mass is going to oscillate at all is if you start it somewhere other than equilibrium. If you start by pulling it down a few centimeters below equilibrium, or I suppose pushing it up a few centimeters above equilibrium. So what the last question is saying is, hang on, is where we start the mass going to affect how many times the mass goes back and forth per unit time? And that seems like to me, that's a very, very reasonable question. Like the answer is either yes or no, but it's not a crazy question. So for the very last one, the only way you can know is you have to test it. Like, so for the very last one, you have to like try starting the mass at 2 centimeters or 2 millimeters or something below the equilibrium place. Make a note with, measure with a ruler where you started from, let it go, and
count.
I'm sorry. A what? Oh, sorry. Okay.
I don't know what to say. What you try to explain.
Wait. Sorry. Oh, okay. Okay. So for the very last one, you definitely are going to you have to test the last one no matter what. It doesn't depend on the first three. And let me also, it's not a trick either. It's like very important. I'm not trying to trick you. The period of oscillation of a spring does depend on things. It's not random. It does depend on stuff. But I'm going to tell you right now, it depends on more than one thing. It depends on the mass in some kind of way. And that's what you're trying to find out. Like the period of oscillation of a mass on a spring definitely depends on the mass in some kind of a way. It either depends on it linearly or quadratically or square rootedly. That's what you're trying to find out. But I'm telling you right now, mass is not the only factor. It's not a trick. There is at least one other factor that period depends on. And that other factor might or might not be initial displacement. So you definitely have to test for initial displacement. And that's one thing. And you'll get a graph, and either you'll be a straight line graph or it'll be a curvy graph. If it's a curvy graph, the answer is no. If it's a horizontal line, then that means the period doesn't depend on it at all. Like if it's a horizontal line, that means no matter what X naught you picked, the period's still the same. That means it doesn't depend on it at all. So then the answer would be no. But if it's a straight line, the answer is yes. Now we're almost done. I know. I mean, we're almost done with this and with the class period. But I have to say one more important thing about these three options. Again, they're not a trick. Period is either directly proportional to the mass itself, or it's directly proportional to the square of mass. Let's look at that third option for a second. Like, what would that mean if the period is directly proportional to the square of mass? Well, it would mean one of two things. If you remember from math, it would mean that if you chose a bunch of different m values and then plotted them against the different t values that you got, according to math, if that third option is correct, that would mean you wouldn't get a straight line, you get a curve known as a parabola, right? Like that's a quadratic function. Maybe you remember from math. If your dots fall in a curve, like this kind of curve, that's a pretty strong indication that t is not directly proportional to m. It's like directly proportional to m raised to some power. If it looks like a parabola, then maybe it's m squared. But how do you know? So that's like a rough thing to say. But again, excuse me for a second. Yes, I'm almost done.
Okay, can I have V-Bucks?
Wait, I'm in the middle of class right now. You can't, as soon as I'm done with class, we can talk about this, but I'm almost done. But when we're done, we'll talk about it.
Okay, but can I stay here?
Well, wait, let me just do class. I mean, sure, yes.
Yeah.
Yes, okay.
Wait, just say hi.
Okay.
Hello.
Okay. Very good. All right, awesome.
Hello.
All right, thank you. Okay.
Hi.
Okay, awesome. Love you. Okay. Should I get a V-Bucks? I don't know. Okay.
Yes.
Yes. Okay. We'll go down.
You should get your son V-Bucks.
Caution, everyone.
The second option. The second. Okay, but now I gotta teach. I got 14 minutes to teach. I've got it. Okay.
Fortnite battle pass.
Yeah, Fortnite Power. Yeah. Okay. Worst parenting mistake I ever made. Okay.
Yes, it's true.
Yeah. Okay.
Also getting views.
Okay. All right. So what on the whole, if your data falls in a curve, then it's not a straight line, then it's not t is proportional to m. But how do you know if it's just a curve? How do you know what curve it is? How do you know if it's a parabola, like t is proportional to m squared, or if maybe it's, if you remember from math, a curve could be a cubic. It could be t is proportional to m cubed. Or how do you know? I'm saying t is proportional to m to the one. Wait, stop. Wait, you got to stop though if I'm going to do this. Like if it's not a straight line, it is some kind of curve, which means it's one of the other options. But how do you know which one? Good question.
Because you
Wait,
draw.
stop. Good question. Here, the hardest thing I'm going to say that might take us some work. It might take you some practice to assimilate what I'm about to say. But here's the deal. If you want to actually verify, for example, choice number 3, or for example, choice number 2, if you want to see whether t is directly proportional to m squared, for example, rather than looking for an exact parabola or an exact curve that you recognize from math, a really important trick in science is to do what we call linearization. A really important trick is if you suspect, if all your data falls into a curve, so you know it's not a straight line, and you know the first option is false, so now you're trying to figure out what kind of curve it is, what you do is make a new graph where, and this is the last thing we're going to say, but I want to make sure you all get this. This is a little tricky. I'm saying if, for example, you want to verify the third option, t is directly proportional to m squared, what you do is make a new table of values where you take each one of your m value, each one of the old m's that you had before, and you square it, okay, and put it into your table. And then you square the m, but don't square the t. So like if, for example, your original ordered pair, your original m measurement was the value 3, and it mapped to a t value of 7, for example. Okay, so just say you had the point on your graph, on your scatter plot, you had 3,7. If you want to test this third possibility, what you do is just square the 3, but don't square the 7. Make a new table of values where you have 9,7, and then you do the same thing for your next ordered pair and the same thing for your next ordered pair, et cetera, et cetera, et cetera. So now you're creating a relationship between the square of all the m's and their corresponding t's. Let me say it one more time because this always throws people for some reason. You would square the m, but don't square the t. And if you make a table of values of these new values and put that on a graph, if the third option is correct, if t is indeed directly proportional to m squared, then you would get a straight line for this. Okay, great. Okay.
See you, class.
Okay, awesome. They love you too. Okay. If, I'm just going to pretend that didn't happen. If, and by that, I mean the last 8 years, if, and I'm just kidding, if t is directly proportional to m, then whenever you plot m on the x-axis and t on the y-axis, you get a straight line. But if t is directly proportional to m squared, then whenever you plot the square of m's on the x-axis and t on the y-axis, then you would get a straight line. Or finally, if you take a bunch of m values and you take the square root of all of them, which is the second option, m to the 1/2. If you take the square root of each m and pair it with the original corresponding t, then if that is a straight line function, then t is directly proportional to m square rooted. Does that, so you want to do that with these. You want to see whether t is directly proportional to m, or is t directly proportional to the square root of m, or is t directly proportional to the square of m. Honestly, it is one of those. I mean, it is. And it can't be all three of those. It didn't have to be any one, but it is one of those. But which one it is, you'll find out by taking data. And I also say, of course, your thing is not going to be perfect, but if your lines are, but no matter what, just know you're looking for a straight line no matter what. It's just you're adjusting the data in advance so that you get a straight line. So if your line is even remotely looks like any of the lines that you got last week, we're calling that a line. Yes, for sure. And you'll really, and you know what, I'm really going to say this too. In a way, this lab will take you a little bit less time than last week because you've already done a lot of the work already. But I'm going to tell you right now, I do expect you to test all 4 of these. Do test all 4 of them, because you'll also, I think 1 or 2 of them will be correct. But test all of them, because also then you may see, again, you'll start to see an answer to Jake's question. Like, I think 1 or 2 of them will be very, very close to a good line, but it won't be perfect. But 2 or 3 of them, well, 2 or 3 of them will look very different. You'll see an exaggerated difference. Nothing will be perfect, but you'll see a range of possibilities if you do test all 4 of these. And let me also remind you that if the answer is no dependence, if something doesn't depend at all on something else, then you would get a straight line, but it would be horizontal. Okay. What else? Okay, I think I'm going to pause. We have like 5 minutes. We don't have to rush. We took a break. We will definitely end on time. But can you just look for a second? Because I know I just said all that in space. I didn't write it down. Hopefully you wrote it down. Can we pause for a second and look at this and ask yourself, could I walk into lab right now and know what I was doing? Especially also now that you know the grading rubric and all of that. All right. Oh, that's Jake. Okay, cool. Thank you, Jake. Okay, but I'm going to pause for a second. I will let you go like a minute or 2 early, but I'm not going to let you go just say, I want to make sure this is that thing I was saying before. I want to make sure everybody has a moment to comfortably look at this. Just don't go anywhere yet. Just take a moment, see if there's anything you don't get. Okay. Can I see electronic hands if you think you are good to go? Thank you, Sylvie. Thank you, Fatima. Thank you, Ashton. Thank you, Kayla. Thank you, Ariana. Thank you, Jake. Thank you, Devin. Okay, cool. Thank you. Oh, thank you, Jonathan. Okay. All right. Then we have 4. I'm going to let you go 3 minutes. One last question. Should I get the second option of VLux is like $20. Should I really get it? I mean, oh my God, I hate Fortnite so much. Oh my God, I love Pokemon. I hate Fortnite. Okay. But okay. All right. No, you guys have been very good. It was a long, long day and a long period. Oh, it's all about Pokemon. You don't understand. Let me just, he and I we actually play the card game twice a week, like out in the town competitively. Like, I mean, TCG. I don't know if any of you actually play. Like, we don't just collect cards, we play. Yeah. Oh my God. No. And he's all, and by the way, he's 8 and he's so much better than I am at the game. And I practice online. We make the decks and everything. He's I'm such an idiot when it comes, okay, sorry. Okay. Wait. Oh, my phone number. Yeah. Hold on a second. Wait, hold on. Oh yeah, absolutely. Yes. Okay. So I'm going to post my phone number right now. Hold on. But also, if it's questions about the homework, you can also use email, of course. But here is my phone number. Okay. And yes, please, next week, for next week too, I'm going to say, because we still haven't talked about this homework, I want you guys to try to help each other with the homework. So please, if there's time, do that. We will eventually let you go early, but not yet. But okay. Okay, sweet Pokemon. Okay, Pokemon leads. Oh, Pokemon's the gateway to Fortnite. Is that your point? Yeah, it probably is. Oh God. Okay, you guys have been great. I'm good if you're good. I will stay in case there's any questions. I'll be the last one to go, but you can go. Thank you so much. Thank you. Oh, it's greater than. Oh, it's greater than. Yes. Cool. Awesome. Okay.
Professor, good
Thank you.
night.
Thank you.
Good night, Professor.
Good night. Thank you so much. Thank you. Good night. Good night, Sylvie. Thank you. Good night. Good. Have a great evening. Thank you. Great, Eugene. Have a great evening. I'll never mispronounce your name again until I do. But thank you. Okay. Have a great evening. Thank you. Great. Awesome. Okay.